Knit fabric construction parameters start with fiber and yarn structure. Fiber characteristics are directly related to the fiber type, such as cotton, polyester, nylon, rayon, or others. Cotton fibers are not as easily stabilized, as are thermoplastic synthetics, because they cannot be heat set to attain stability. Synthetic fibers do not exhibit the swelling-deswelling scenario that cotton exhibits. The comfort and overall appeal of natural fibers, especially cotton, have driven consumers to prefer them. Therefore, the production of stable cotton products is essential. Yarns are made with fibers, and therefore they exhibit the same characteristics as the fiber. Yet the manner these fibers are oriented in a yarn will affect certain properties of the fabric, including shrinkage. Yarn parameters are an extremely important part of fabric construction specifications. Yarns can be defined by size, type, twist level, twist direction, and configuration. In addition to the impact on fabric construction, yarn parameters also relate to fabric costs. Yarn size has an impact on and relates to fabric yield, width, and shrinkage. Yarn type means either ring spun, open end, rotor spun, or air jet. The yarn type has an impact on skew, appearance, strength, hand, and has a marginal influence on shrinkage. Twist direction refers to the spiral twisting of fibers during yarn formation and is either Z-twist or S-twist. Cotton singles yarns of high twist will yield greater skewing or torquing of a single knit fabric. Twist multiple refers to the level or intensity of twist and has an impact on skew and fabric softness. Twist has a marginal impact on shrinkage. Yarn configuration relates to whether there's a single strand of yarn, two yarns plied together, or two single yarns knitting together. These relate to skew, costs, appearance, strength, and hand. Fabric construction has an impact on the shrinking characteristics of a fabric. For example, the performance of a single piqué is certainly different from that of a single jersey or interlock made from the same yarns. Each has different construction parameters and will deliver different specifications of weight, width, and shrinkage. Important construction variables include yarn, machine gauge, machine diameter, stitch length, and the type of stitch used. Knitting machines are designed so that needles are placed in individual grooves cut into the outside of its metal cylinder. The cuts or grooves may be referred to as slots or tricks. These cylinders are precisely manufactured so the diameter measured at any place is equal. Machines are classified by the number of cuts per linear inch. This is referred to as the cut or gauge of the machine. For example, an 8-gauge machine has 8 cuts per inch. The total number of cuts around the circumference of the cylinder indicates the number of needles in the cylinder. The number of needles, along with the yarn size and the stitch length, are important factors that determine the width of the fabric. The cut of the machine establishes the range of usable yarn sizes. For example, finer gauges can use finer yarns. Stitch length is the basic building block in knitting. It affects the weight, width, and shrinkage of the fabric. Stitch length is defined as the amount of yarn in one stitch repeat. The red shaded loop is one repeating unit of the single jersey. The length of yarn in this loop is the stitch length. Stitch length is referred to as loose, medium, or tight. A loose stitch has more yarn and makes a larger loop. A shorter stitch length has less yarn and results in a tighter stitch that yields less length shrinkage, more width shrinkage, a narrower fabric, and a heavier fabric. Course length is the length of yarn used by each yarn feeder in one revolution of the knitting machine. Stitch length is determined by dividing the course length by the number of needles in the cylinder. For example, if a machine with 1,500 needles has a course length of 200 inches, then the stitch length would be 0.133 inches. This was determined by dividing 200 inches by 1,500 needles. Another important manufacturing parameter related to shrinkage is the type of stitch used. There are only 3 types of stitches in weft knitting: knit, tuck, and float. When tuck and float stitches are used with jersey, the results are predictable. Let's take a look at the first one, the knit stitch. If every needle is fed a yarn and goes through the basic knitting cycle, the resulting fabric is single jersey, All the loops have the same shape and size. Therefore, each would have the same shrinkage characteristics. The second type of stitch is referred to as the tuck stitch, because one yarn is tucked behind another and hides. The illustration on the left shows the technical face of a tuck stitch. Follow the colored green course of the yarn across the pattern, and it looks like a loop has been tucked behind another. The illustration on the right shows the technical back of a tuck stitch. From the back, the tucked loop is more visible to the eye. Tuck stitches are constructed with an elongated loop and a tuck loop. In this illustration, the elongated or held loop is shaded red, and the tuck loop portion is shaded green. The stress caused by holding one elongated stitch for an extra course causes more length shrinkage, but less shrinkage in width, than a regular knitted stitch. Therefore, addition of tuck stitches to jersey stitches creates fabric that is wider, thicker, and less extensible. The fabric also has more length shrinkage and less width shrinkage. The structure of the fabric is also affected by tuck stitches. Tuck stitches can give a fabric a cellular appearance, often called mesh. Tucks are the basis for piqué structures, typically used for golf and tennis shirts, which need to breathe and retain their shape but have some stretch. A wide range of piqué constructions can be made, depending on the use and frequency of tuck stitches. The third type of stitch is the float, which is also called a miss stitch. The illustration on the left is the technical face. On the face, in the middle course of yarn and middle wale, it looks like the machine has hidden the colored yarn in the back. It is not captured or knit with any other stitch. This is the float or miss stitch. On the technical back, you can see how the loop floats. Loops can be made to float over a series of wales. To make the structure secure, some float yarns can be tied into the ground with a jersey or tuck stitch. Floats are useful for pattern effects where some colors appear on the front and others are hidden on the back. This checkerboard pattern uses black and white yarns. When the black yarn knits, forming a black square on the front, the white yarn floats to the back. If you turn the fabric over and inspect the back, the colors appear reversed. Float loops make the fabric more narrow, thinner, and less extensible because the floated yarn is in a straight configuration. Knit fabrics can be made with more than one set of needles. Single knit fabrics are made with one set of needles, and double knit fabrics are produced on two sets of needles. Rib and interlock are the two most basic double knits. Both use only the knitted stitch on all the needles. To accomplish this, a second set of needles is located in the dial, which is arranged above the cylinder. This dial has slots that hold the needles at a right angle to the vertical cylinder needles and will be of the same gauge or cut. Rib knits are made on a cylinder and dial machine where the needles are arranged in a staggered configuration, which is called rib gating. This drawing shows a 1x1 rib, where the cylinder and dial needles knit jersey on all needles, alternating from cylinder to dial. Interlock knits are made on a cylinder and dial machine where the needles are arranged in an opposing configuration, which is called interlock gating. Because the needles are opposed, they cannot all knit in sequence. This illustration shows the interlock construction. At the first yarn feeding position, the odd-numbered cylinder needles knit, and the even-numbered dial needles must knit. On the next yarn feeding position, the needles that didn't knit at the first feed will now knit. It's easy to see that it takes 2 feeds to knit 1 repeat of interlock. Because the loops interlock and alternate from the front to the back, the structure of interlock fabric is much more rigid and dimensionally stable than that of a rib fabric. When more complicated double knit fabrics are produced, combinations of the knitting stitches can be used. Constructions can be made with jacquard selection of the needles, where tuck and float stitches can be added to the jersey stitches. The resultant fabrics will take on the shrinkage characteristics of the type of stitch used. The introduction of tuck stitches will cause more length shrinkage and less width shrinkage.